Hello, guys. So let's get started. Today we're going to be talking about maps. I'm going to break this into 2 days. So it's one PowerPoint presentation, but it'll be 2 days of maps. So day one, we're going to start with basically reviewing latitude and longitude, get into a couple details there. So this is your warm-up. And what I want you guys to do is to look at the letters and try to identify the latitude and longitude of each of those locations, A through I. I will post the answers for you guys so you can check your answers. However, just a couple reminders. You're going to be writing your latitude first and then your longitude. And those numbers are going to be separated by a comma. So, for example, I'll just do letter A with you. Letter A, if you notice, is located in the water just near Australia. And the latitude of that location is 20 degrees south. So we would write 20 degrees south, comma, and then we're going to follow that line all the way up to the top. And the longitude is 100 degrees east. So we would write 20 degrees south, comma, 100 degrees east. And you're going to do that for each of the letters. And I'll post your answers so you guys can check it. Now, I do want to say, for those of you that warm-up is easy and you remember all the details about latitude and longitude, please feel free to skip through this section. And my intention is not to bore you guys with information that you already know, but I do want to make sure that we're all starting off on the same page so that we can really work on reading and interpreting all different types of maps. And our intentional learning objective for today, our objective is that you will be able to read and interpret different types of maps and different types of map projections. So we'll keep that in mind as we go. Remember that a map is a representation of an area, and it's used to show physical features and exact locations. Latitude are imaginary lines that run parallel to the equator, and they're also sometimes called parallels. And the important thing to remember about latitude lines is that they never intersect. The equator is our main reference line at 0 degrees latitude. The North Pole is at 90 degrees north latitude, and the South Pole is at 90 degrees south latitude. The way that you will find your latitude is to calculate the angle of Polaris, and that will be equal to your latitude. Polaris is the North Star. I think you guys remember that. But Polaris is the star in the sky, the brightest star in the sky. And you calculate the angle of yourself to Polaris, and that tells you your latitude, just to be sure. Okay. Longitude, on the other hand, are lines that measure distance east and west of the prime meridian. And they're also called meridians. And the main reference line of longitude is 0 degrees longitude, which is the prime meridian. Now, the difference between latitude and longitude is that 0 degrees line does not continue all the way around the globe. So on the opposite side of the globe is the international date line, which is 180 degrees. And the really interesting thing about the international date line is that when you cross it, you either go forward one day or back one day. Actually, it would be forward one day, back one day. My camera's backwards. The international date line is in the Pacific, and they've kind of moved it a little bit so that it doesn't really cross any land. Moving towards California, you go backwards one day. So if you were traveling from, let me figure out my backwards camera. If you were traveling from Asia to California, you go backwards a day. And if we're going from California to Asia, you would go forward one day. Another important thing to remember about latitude and longitude, besides that latitude is written first and longitude is written second, is that we kind of try to remember that if you look at it alphabetically, LA latitude comes before LO longitude. A comes before O in the alphabet. So if you can't remember that latitude is written before longitude, try to think back alphabetically that LA comes before LO. And then another thing that always helps me with remembering the difference between latitude lines and longitude lines is that latitude lines are like rungs on a ladder. So their latitude lines are like rungs on a ladder. And remember, the lines go this way, but they're measuring north and south of, pretend this is the equator, okay? So latitude lines are like rungs on a ladder, and they measure north and south of the equator. Longitude lines, on the other hand, are long longitude. Imagine that this is the prime meridian, and they measure east and west of the prime meridian. So those lines go straight up and down. And we'll talk about some exceptions to the rule of them going straight up and down as far as when we're talking about maps. But in general, your latitude lines run like ladder rungs, and your longitude lines run up and down. Two important parallels are 23.5 degrees north, which is the Tropic of Cancer, and 23.5 degrees south, which is the Tropic of Capricorn. And other important lines of latitude are the Arctic Circle at 66.5 degrees north and the Antarctic Circle at 66.5 degrees south. Be sure that you also include your direction with your latitude and longitude. So we write latitude first. We don't want to just put the number. So like, for example, in our letter A, it was 20 degrees south, not just 20 degrees, because there's a 20 degrees north and there's a 20 degrees south. So you want to make sure that you're doing the direction as well as the number, the comma, and then the longitude is also telling us either east or west. And that's just an example. And actually that one includes the minutes. Absolute locations are always given with latitude first and then longitude, ABC order, which I also talked about. Subdivisions of latitude and longitude are that 1 degree is divided into 60 minutes, and then 1 minute can be divided into 60 seconds. So that gives you an even more accurate representation of a location. And this is just an example of a subdivision of latitude and longitude. Okay, so we have 2 practice questions. You guys have these in your notes too. So let's look at the one on the left first. The longitude of Richmond, Virginia on the above map is approximately what? So we're looking at that letter R and where the dot is, and we're looking for the longitude. So the lines that run up and down. But don't get confused, because the lines that run up and down, the numbers that go with them are on the top and on the bottom, sometimes on the bottom. So we're looking for the point between those 2 lines, and the 2 lines are 90 degrees and 75 degrees. So it's got to be somewhere between 75 and 90, or somewhere close to 75 and 90. So that means that our best answer there is going to be 75 degrees. And is it west or north? So longitude lines, remember, measure east and west of the prime meridian. So if we're looking at longitude, we are looking at degrees west. So the answer there is F, 75 degrees west. The question on your right, the wireless operator above the Titanic signaled for help and gave the ship's location as 41 degrees and 45 minutes north and 50 degrees and 14 minutes west. Which area shown on the map is most likely where the Titanic struck the iceberg? So we're going to try to locate 41 degrees and 45 minutes north. So let's look for 41 degrees and 45 minutes north. And those are your latitude lines that run this way, but the numbers are on the side. And so we've located that area is sort of just a little bit above the 40-degree line. And then 50 degrees and 14 minutes west. So we're looking for something a little bit to the left of 50 degrees. And it looks like the one letter that's closest to that location would be the letter A. So the answer there is A. Now there are a couple different ways to represent scale on a map. And one of those ways is with a graphic scale. So with a graphic scale, you would take a piece of paper. Let's see if I have a piece of paper here I can show you. This is just a random piece of paper. You're going to take your piece of paper and you're going to actually hold it up to the map and make a little mark with your pen or pencil, the distance that you're trying to measure. So let's say the distance between two cities I've marked with my pencil, and it's this distance. Then I'm going to take that and hold it up to my scale to figure out what that actually represents in real life. That's what a graphic scale is. A verbal scale is, for example, would be like 1 centimeter equals 1 kilometer. So every centimeter that you measure on the map equals 1 kilometer. And then a representative fraction, which you don't necessarily see as often, is just 1 to 100,000. So 1 inch might be equal to 100,000 inches in real life. So those are 3 different types of scale. So these 2 questions I've seen so many times in my earth science teaching life, but they are good practice because it forces you to practice using that graphic scale. So by how much has the length of the delta increased from 1982 to 1996? So you would take your piece of paper and you would hold it up to the screen, and then you would measure and make a mark. This is probably going to have some ASMR noises from a paper. And then I'm going to take those marks and I'm going to hold them up to the screen, and it looks like it is going to be 4 kilometers is the correct answer. If I measured from 1982 to 1986, I got this as my answer. Whoops. Right there. And then I held it up to the scale, and it was exactly 4 kilometers. Okay. The next one asks you, it says the picture shows the path of a forest fire that started at 5:30 a.m. It travels at 1 kilometer per hour. About how long will it be before the fire reaches the ranger station? So it doesn't really matter what time it is, because it's not asking you to tell you what time it's going to arrive at the ranger station. It's just asking us how long it's going to take to get to the fire station. So we want to see in the period of time from the end of the path of the fire to the ranger station how long that's going to take. So again, we're going to take our paper, we're going to hold it up, we're going to measure from here to here. Then we're going to hold it up, and it looks like it's about 1 kilometer. And then, so 1 kilometer per hour. So the answer would be 1 hour. And I did the same thing that I did before. I just held up my paper. I did a measurement with my pen. I saw how far it was from one edge to the next, or from the edge of the fire to the ranger station. And then I held it up to my kilometer mark, and it was almost exactly 1 kilometer. So if I know the fire travels at 1 kilometer per hour, then it's going to be about 1 hour, which is G. Okay, so time zones are important too when it comes to maps. And remember, Earth's rotation is the basis for local time. Remember, Earth is a sphere, and it's 360 degrees, and we know it takes 24 hours to make one complete revolution on its axis, or rotation on its axis. And at that rate of 360 degrees in 24 hours, that's about 15 degrees per hour. Therefore, Earth is divided into 24 15-degree time zones, and that's how we got our time zones. Remember, each time zone is 1 hour different, and each time zone covers 15 degrees of longitude. Also, there are 6 time zones in the United States. And this is a map that shows you all of the time zones in the world. And you can see our 6 time zones now in the how do you say that word? Continuous, whatever, United States. The part that everybody thinks of when they think of the United States, there's 4 time zones. So we have going from this side with my backwards camera, the Eastern time zone, and then Central, and then Mountain, and then Pacific. And then we have the Alaska time zone, and then we have Hawaii time. So that's where the 6 comes into play. So we only have 4 in the main part of the US, and then Alaska has its own, and Hawaii has its own. And that is it for the introduction part of maps. So I'm going to stop here, and we'll come back tomorrow with day 2, and we'll continue with the different types of maps. So I will see you guys tomorrow.